Hello students and welcome to another video lecture from Architects Academy. Today we are going to learn about the concept of plan, section, elevation, and we are going to see how 3D objects are drawn in different types, like for example isometric view, axonometric view, perspective view, and so on. So let us first see what is meant by plan, what is meant by elevation, and what is meant by a section. So if you look at this particular object, what you will see is that when we view this object from the top, what we see is the plan of the object, and it is represented like this, the plan of the object. If we look at the object from the sides, that is all the four sides, then we are going to see the side of the object, and this is going to be called as an elevation. Now similarly, if you actually cut the object, like this is what we are seeing here, that this particular cube is being cut by a plane. Imagine this to be a knife, and this knife is cutting through this particular cube. And if we separate these two parts out and see the cube, what you're seeing here right now is that this particular cube is made out of a material which has got some thickness, and from inside this cube is hollow. So if you look at the section of this, that is, if you look at the side, from the side, if you look at this particular object, what you're going to see is something like this. So this is representing a section. So what you will see is that whatever has been cut in section has been shown with a hatched line, which had hatched lines, and we can now understand whether this cube is hollow or whether it is a solid cube. By just looking at the plan and elevation, we cannot understand what is inside the cube. So in the next cube here, what is shown is again a similar cube, but this has been cut. But right now, in contrast to this, what you will see here is that this cube is totally hollow from, it is totally solid from inside. So what you're going to see is a solid section. So now what we'll be seeing is the section like this. So you can understand what is the difference between this section and this section. So a section is also necessary to describe a particular object, whether it is hollow or whether it is completely solid. Also, you will find that the section will also give the information about the material which has been used for the cube. For example, this could be made out of steel or some metal, or it could be made out of timber. So then there are different methods by which we represent whether this is steel or timber or whatever. So the different type of hatching is used for different types of materials. And therefore, we are trying to use these methods to understand whether this object is solid or whether it is hollow and what type of material is used in it. So now let us see what is meant by isometric view. So isometric view is a 3D view, but in this view, this is drawn in such a way that the horizontal lines are drawn at 30 degrees, which are parallel to each other, while as the vertical line remains vertical. So this is a technical view, and you can actually take measurements from this particular view and look at the object. So the objects, when they start becoming bigger, when we start drawing isometric views of bigger objects, then they start looking unrealistic and distorted. So similar to the isometric view, you can also see that there is axonometric views, in which case the horizontal lines are drawn at 30, 60 or 45, 45 degrees parallel to each other. Vertical lines still remain vertical, and objects can again look unrealistic and distorted once the size of the objects becomes bigger. So here there is an example of showing an isometric view where the horizontal lines are drawn at an angle of 30 degrees. So now, why do we need a perspective view? So as you will see that in this particular case, the distortion of the object is not so clearly visible because the object is a small object. But once this object starts becoming bigger, the distortion of the view starts becoming more. Now you know that architects normally deal with large objects like buildings. So we don't see objects like we are seeing here in isometric view. But in actual reality, what happens is that in case of a perspective view, the horizontal lines, they vanish towards a vanishing point and they are not parallel to each other. So we don't see the horizontal lines parallel to each other. And therefore, when we draw a perspective view, we always have a vanishing point. And this vanishing point is the point where the horizontal lines will vanish. Now, depending upon the type of view, the perspective view can be 1-point view, 2-point view, 3-point view, and so on. So we'll be learning more about this as we go along. So perspective view is a technique which is used to represent the object by the architect, and you will see that the perspective view gives a more realistic impression of the object than the isometric view. So I had already mentioned this, that the uh, perspective views can be 1 point perspective, 2 point perspective, 3 point perspective, and so on. And again, there could be another classification of perspective views, that is either it's a bird's eye view or eye level human eye level view or a worm's eye view, and so on. So depending upon how many number of vanishing points are there, the perspective views can be classified into 1, 2 and 3 point perspectives, and based on from where the object is being viewed, that is the eye level of the observer, we can classify them into bird's eye view, then human eye view and worm's eye view. For example, if the object which we are seeing is seen by a bird, then what you will be seeing is mostly the top portion of the object, while as if a worm is looking at the object, the worm will see mostly the sides and the bottom of the object. So this gives a different point of view based on the eye level. So let us see that further. So there are some terminologies which you should understand in perspective view. So the first terminology is the horizon or eye level. So we'll see that when we are going towards the examples. So remember that the two important concepts which are there is horizon line, and horizon line is the same as the eye level of the observer. So what we are going to see is that when we are looking at objects, we are going to be important point is going to be the horizon line and the vanishing point. So let us look at this particular example. This example is giving you a 1 point perspective. So in the 1 point perspective, what you are seeing is some concepts. This is a railway line which you are seeing, and if you look at this railway line, actually in reality what happens is that these two rails are going to be actually parallel to each other. But when we look at this particular railway line from a distance, you don't see the two lines parallel to each other, but what you see is that they tend to vanish towards a vanishing point, far away into the horizon. So what you'll see is that this is called as the horizon line, and this horizon line also represents the eye level. This particular point to which all these objects are disappearing, the horizontal lines are disappearing, this is called as the vanishing point. If you look at the poles which are on the side of the railway line, what you are going to see is that these poles also, though they are of similar height, actually in actual reality they are of the same height, but what will appear to us is that the height is going on reducing as they go towards the vanishing point. Not only that, you will also observe that the distance between the objects, that is the horizontal distance between the objects, will start looking closer and closer as we go towards the vanishing point. So this is an important concept that you should understand in the 1 point perspective. So similar 1 point perspective is shown here, but instead of a railway line, we are showing a road and the buildings around it. Now you will see that all the lines in this particular perspective, they are all vanishing towards the vanishing point here. The lines of the roads, they are also vanishing. The window lines, the line of the roof, everything, any horizontal line is now vanishing towards the vanishing point. But look at the vertical lines. What you will see is that all the vertical lines are remaining vertical. So they don't vanish towards any vanishing points. Similarly, the horizontal lines in this particular plane, in the plane of the paper, you will see that they will also remain horizontal. Only the lines which are going towards the vanishing point, these horizontal planes will vanish towards the vanishing point. So this is an important point to note. And when you are going to draw 1 point perspective, this is one of the important rules that you should always use, that all vertical lines will always remain vertical and the horizontal lines in the plane of this particular view, they will always remain horizontal. So this is another example of a 1 point perspective. Again, you will observe the similar thing, and you will also observe that this particular line, this is the horizon line now at this particular point, and this is roughly now with respect to the human eye level, and therefore what we are seeing is as if we are personally walking on this track and we are looking at the object. If a bird was to view this thing, it would have been totally different thing. In that case, the eye level of the bird would have been much different than what we are observing. Now let us see what is meant by two-point perspective. So instead of one vanishing point, in two-point perspective, we are using two vanishing points. So in this case, what you will see is that only the vertical lines are remaining vertical, and all the horizontal lines, they are vanishing towards the vanishing points. So what you will see is, now in this case, there are no horizontal lines in this view. There is only vertical lines, and there are inclined lines. These inclined lines are those which are vanishing towards the vanishing point. So in two-point perspective, one important point to note is that all vertical lines remain vertical, but then there is no set of horizontal lines which you are going to see in a two-point perspective. All horizontal lines are going to vanish towards the vanishing point. Now let us see the effect of eye level with respect to how the objects are seen. Now you will see here the same cube. There is a similar cube but drawn at different eye levels. So what you are seeing now here is that when the eye level of the observer is below the vanishing point, what you will see is that the bird's eye will be seen. That means that somebody from above is observing this object, and therefore this top of the object and the side of the objects will be seen. If you are standing in front of this object at a human eye level, then what you're going to see is you're going to see only the two sides of the object, and the top and the bottom of the object are not seen. Now let us see what happens if you are a worm, or if the object is lifted up with respect to the person who is standing here. What you will see in this case, you will start seeing the bottom of the object and the two sides of the object, and you will not see the top of the object. So this is an important point which you should note uh, when you are thinking about eye level and perspective view. So this is showing you another example of a two-point perspective where you are having two vanishing points, and this is the sort of a house. Now this is the type of drawings which the architect could make, like a building. And now in this particular case, you will see that all these lines which are horizontal in actual reality, these are going to vanish towards the vanishing point, whereas all vertical lines, they are remaining vertical. They don't vanish towards any vanishing point. So this is called as a two-point perspective. So this is about 1 point and 2 point perspective. We'll learn about 3 point perspective in the next lecture. I hope this is clear to you up to now. So we'll learn further about this in the next lecture. Thank you.